For the second part of the lab, we're going to add some new switches. So the theory is, oh hey, we have this network that's kind of just cobbled together. Let's add a new switch, and we're going to add one of these multi-layer switches we haven't really messed with. And now there's some things we have to do to implement this switch into our network. So we're gonna implement the switch into our network for VLAN 2 and VLAN 3. So the first thing we need to do, well, I don't know, maybe not the first thing, depending on how you like to operate. The first thing I'm going to do is I'm going to connect it to the new network, in theory, with two links. All right, so I connected that in. Did that turn those links? They're orange now. We'll wait till those guys come up. We'll wait till those guys come up and then see what we can see. Well, again, it'll take about 50 seconds, so if you're bored, you can like take this 25 seconds we have remaining and do whatever you want. Okay, so we have a green on one side. And we have green on the other side, but it's blocking, so that's kind of expected. So we're going to run the command show spanning tree, right? Show spanning tree, all that shows up is VLAN 1. That's weird. And, you know, why didn't the other VLAN show up? Well, let's look at that. We don't have any trunk interfaces, so since we don't have any trunk interfaces, we're not getting any VLAN 2 or 3 traffic across the switch. So we need to make those switch ports trunk. So I plug that into 23 and 24. So we'll make these guys trunk. All right, this particular switch says we have to set the encapsulation type, so we will do switch port trunk encapsulation .1Q. Why don't our other switches make us do that? Well, because they only support .1Q encapsulation, so that is why that is the case. So now we'll do show spanning tree again, and that's weird. We only get VLAN 1 still. So here's another thing I guess I could have pointed out. During the spanning tree process, you can see the port status. Like I just ran it. This one says it's listening. And I ran it again. It says it's learning. If I run it again, it should probably be forwarding. Yeah, so we're forwarding for VLAN 1. So that's weird. Let's see if we have trunks now. Okay, we have trunks. And we have all the VLANs are allowed, but VLAN 1's only allowed and active in the management domain. We're only getting VLAN 1. So what does that mean? Well, that means we have no VLAN 2 on this switch. Not show spanning tree, show VLAN. So we still don't have VLAN 2 on the switch. We're not using VTP or anything to automatically copy the VLANs over. So since VLAN 2 doesn't exist, we need to create VLAN 2. And the way we can create VLAN 2 is just by typing VLAN 2. Did that create VLAN 2? Yeah, so that created VLAN 2. We're going to do the same thing for VLAN 3. So now we have all the VLANs. So the VLANs exist now, so now we should probably get some spanning tree stuff for the VLANs, right? Yeah, now we have spanning tree stuff for the VLANs. So when you're implementing your new switch, you have to make sure you create the VLANs you need on it if you expect it to be part of the spanning tree. So it's doing the listening and learning. We do show int trunk, the stuff shows up, all the VLANs are there now. So that's good. If we were to implement this new beefier switch in our network, it's probably more powerful. So we would probably want it to be the spanning tree root bridge. So we're going to set it like that for VLAN 2. So if we look at this setting, we have a priority of 32770. and it's far away from the root. So if we want to make this guy the root bridge, we can make it the root bridge by saying something like spanning tree, root, spanning tree, VLAN to root. So we can either say, hey, make this switch the root switch, or we could set the priority to a lower value than the other switches that exist. But this is going to be the easiest way to do this. And then we have primary or secondary. If I had another one of these guys up here and they were working together, I could make it set a primary and secondary. So I'm going to set this as the primary. And let's go see if I had a ping still going. Oh, that was VLAN 3. I did that for VLAN 2, so my ping's not going to be affected. We'll do it again for VLAN 3. So now if I do show span VLAN 2, this bridge is now the root bridge. So if we went to look at the other bridges, we would see they're not it's not the root bridge anymore, and the priority value changed. It was like 32,770 or whatever. Now it's 24,578. So that's the root bridge. Now we're going to do the same command for VLAN 3 and see if our ping fails. It might, because we're having a spanning tree topology change event, so I would kind of expect it to fail. But maybe it's not going to. Oh, because I didn't actually run the command. I said show spanning tree VLAN 2. Let me run the actual command. That might be cool. All right, so there we go. We just changed our spanning tree topology, and that caused a outage, momentary outage. Again, you know, screwing around with things you might not think would cause a problem actually did cause a problem. So that's not real cool. So we do show spanning tree VLAN 3. This guy's the root bridge, which is what we expected. We're probably going to have 50 seconds of downtime. So we'll just leave that go over on the side. The two more things we're going to talk about in this lab. One is we're going to configure portfast. So I've mentioned portfast like 1,000 times, or spanning tree when we've been in the lab, because as you probably remember, you know, we connect a interface to the switch, and it goes orange first. That's while spanning tree. That is why happens while spanning tree. Our ping came back, in case you're curious. That happens while spanning tree is doing its whole listening and learning nonsense. So if we know for a fact that a port is never going to have a switch on it, we can tell it to enable portfast, which essentially allows a port to become active as soon as it's connected. So we're going to delete this link again, and this time when we connect it, it should go to green pretty quick. Yeah, did you see that? It went straight to green. There was no orange. So in the real world, if you have PCs and servers connected to a switch, you should probably enable portfast on those interfaces, so that, you know, if your server takes a little momentary blip on the connection, it doesn't stay down for 50 seconds. It can come back up immediately, because there's really no reason not to have those switch ports come up immediately if you know there's going to be PCs and servers connected to them.